So hello dear students. Yeah, thank you. So is it audible? Can you just confirm whether the audio and video is fine? Yeah, thanks. Can someone confirm that whether the audio and video is fine? I think वो हिल गया ना? Okay now? Yeah. Okay. So yeah. So guys, can you confirm in the comments whether it is audible or not? Okay. Can someone confirm? That red pointer is visible. Huh, ठीक है. Right. Yeah. So guys, we'll be doing full screen of YouTube is not working. Sir, full screen of YouTube is not there. So what should we do? Just check. Yeah, yes, yes, Nikhil, we are just starting. Is it everything? Can you just confirm that audio, video, everything is fine? Yeah. Audio and video is fine, just video is not in full screen. Okay, we are just checking that. Just give us a minute. Okay. We'll just cross check that. Yeah, the team is checking that. Just give us 1 or 2 minutes. We'll cross check that. Yeah, is it okay? Yeah, can someone confirm? Is it okay now? Yeah. Yeah, so Kundan, I'm good. What about you? Huh? So black screen has come up. I'll just check. Yeah. Yeah, we are just checking that. Just give us a second. Yeah, guys, can you tell now? Is it okay? Is the screen, audio, video, everything is okay? Fine. Yes, Kundan, thank you. Yeah, so yes, I think everything is fine now. So let's start with the session. Okay, so hello everyone. I think we guys will keep the session as interactive as possible. I'll also be solving questions, but I think what we will do is I'll give a question and see how you guys are able to attempt that question, and then we will see how the things are going on, right? So we are starting with a session on theory of computation. I think you guys had wonderful sessions on database management systems yesterday and day before yesterday, and I am here with the session on theory of computation, right? So right, so let's see. So I think I'll ask the first question from yours, from you people only, that which topic do you think has the highest weightage in theory of computation? So if we talk about theory of computation, just let me know what do you guys think has the highest weightage in your comments. And I also gave a brief hint when in the introduction video. So in the introduction video of the GSB, that is the Gate Score Booster, I also gave a brief hint that which topic is the most important topic. Yeah, thanks, Nikhil. Okay. So I think Gagan thinks regular language. Yes, Gagan, it's an important topic. Kundan thinks regular language plus regular expressions plus regular grammar. Okay, it's important, right? You are correct. Okay. Little below. Okay, I'll do that. Is it okay? Right. So so if we see, right, you guys are correct in this, right? So स्क्रीन थोड़ा इधर हो सकता है क्या? स्क्रीन मेरे को कमेंट्स नहीं दिख रहा है. हाँ, वॉल्यूम कम करना है. Right, right. So yeah, so you guys are correct in saying this. When you said this, I think few guys have correctly identified it. So identification of language is the most important thing, and that is what we are going to cover today. So identification of the class of the language is something which we will discuss in detail today. Identifying the class of the language. Right? That is one thing. Apart from this, people also talked about decidability, and also people also talked about decidability and undecidability. Yes, definitely, that's also an important topic which we will cover today itself. That is decidability and undecidability. Students, limit state. Right. That is the second topic which we will cover today. And we will also talk about the closure properties. So if you look at the GATE exams, last 2 to 3 years, a question has been asked on each of these topics. At least one question has come up. So that's why I have chosen on day 1 to cover these topics, right? And so let me write down the third topic for today, that is closure properties. This we will cover today, right? So in general, I will also cover the brief theory behind the questions also. In case you do not know the concept, don't worry, we will cover the theory, not in detail, but that much theory that will so that you are able to solve the questions properly, right? And so if you have a feeling that I do not have brushed up the concepts, don't worry, we'll brush up the concepts on the way, right? So you don't need to worry about these. But the session, for the keeping the session to be interactive, what I will do is I'll give the question to you, give you some 2 minutes to solve that questions. Once you give the answers, then I'll explain the answer to you, right? So this is how we will continue, right? So so here is the first question for you guys. Yeah, so I'll give you some 2 minutes to solve this question. Okay. So yeah, So you guys have some 2 minutes to solve this question, and then we will discuss the solution for the same. And I'll also discuss the brief theory behind it. So Kundan says the answer is A, B, C, D. No, Kundan, the answer, you are incorrect. Just look at the question once again. Like. So I have not yet got any correct answer. Gagan says A, B, D. Yes, Gagan, you are correct. Answer is A, B, D. Kundan, you are also correct. A, B, D is the answer. What about others? Where they stand? I'll just give you 2-3 more seconds to solve it, and then I'll solve it for you guys. Yeah, any other answers? ABD is the correct answer. Okay. Saryam, sir, recursive means Turing machine, right? Yes, Gagan, you are correct. But that means the halting Turing machine, Gagan. Recursive means the halting Turing machine. You are correct while saying that. So, okay. So, let's discuss the solution. So, ABD is the correct answer. I think many of you have answered this correctly. So, let's see. When I say which of the following statements are correct, so we'll have to look at all the options, and I have kept the question as an MCQ question, right? So let's see. The first language says L1 is equals to WXW, and WX belongs to AB star, is a deterministic context-free language, right? So over here, what I can do is in L1, the language given is WXW, right? Now X can take the values AB star. What I can do is I can keep my W as epsilon and this W also as epsilon. So this becomes sigma star, which is a regular language. Idea. And since we assume some weight efficiency, I can say that it is a deterministic context-free language also, right? So in general, yes, Kundan, you are correct. Language is language is regular. So see, if it is regular, we can also say that it is a deterministic context-free language also, right? So option A is correct. Is it right? Yeah. Okay, so Kundan, some other subject lecture sound is coming in between. Okay, I need to check this. Just a second. Sometimes. Okay. So, okay, if it comes again, just Kundan, let me know. We'll cross check that why it is happening. Yes. Right. Yeah. So next option says WCW, where C is a spatial symbol, is a recursive language. Now you see over here in this case, When C is a spatial symbol, you cannot make W's as epsilons, right? And in this case, you have to compare W's. Therefore, it becomes context sensitive language. And since it is context sensitive language, we can simply say, yes, it is recursive too, right? I'll briefly explain the theory to you guys also, so that all of you are also able to understand it, right? If somebody doesn't know the theory. So therefore, option B is also correct. Since it is context sensitive, it is also recursive language, right? So option A is correct. Option B is also correct. Coming to option C. Option C says WXW, where WX goes to AB plus is a deterministic context-free language. Now, it says a deterministic context-free language, right? So let us see whether it is a deterministic context-free language or not. So now in this case, we have W, X and W. Now in this case, W can go to AB plus. So at least one length string is needed. At least one length what is needed for W, X and A, right? Is it okay to everyone? We need at least one length string is needed for W, X and A. Is it okay? Okay, I'll think we'll cross check Tejasvi about it. Just give me a moment. Yeah. Come. So guys, we have told the technical team regarding this. They'll resolve the issue. So meanwhile, we'll keep on continuing. So right. So now we have a WXW. At least one length string is needed for WX and A. In this case, X cannot eat up the entire string. So for example, if X starts eating up this, at least one letter has to be left. I can write. So in this case, if only one letters have to be kept, rest everything is taken by X. In that case, we have to compare the first letter with the last letter. We have to compare the first letter with the last letter. And in this case, we are not sure that whether it will match or not. So we will require a context sensitive language to do that. We will require a context sensitive language to do the same. Therefore, we can simply say that L3 is a context sensitive language. Therefore, it cannot be deterministic, right? Is it okay to everyone? Yes. Is it okay, everyone? Yeah. Okay. So now we have L4, which says L4 says WCW, where W belongs to AB plus and C is a spatial symbol, is a recursive language. Let's analyze this language also. So let's analyze this language also, which says WCW, W belongs to AB star, where C is a spatial symbol. In this case, you have to again match this W with this W. Therefore, you will require a context sensitive language to do this, right? You will require a context sensitive language to do this. Therefore, I can say this language is context sensitive. Therefore, it is also recursive. And thus, this option is also correct. So therefore, option A, B, and D all are correct, but C is false because it is a context-sensitive language, right? The first symbol has to be compared with the last symbol, and we cannot say that which one is correct and which one is not correct, right? We cannot write a regular language for the same. So Kundan says for matching last and first, we can do by CFL non-deterministic. So, okay, so Kundan, but I think you cannot, right? How would you do that? You cannot do that because, how would you do? Because you have to compare the first letter with the last letter, and therefore, for example, if I try to write a regular expression for the same, if I write it as A plus B star, A, and I write it as A plus B star, B plus A plus B star B, then in this case, you cannot say so that this is enough, because for that you will require more knowledge, because there are more strings in this which are there. For example, a string starting with A may, so the string can, for example, let me give you an example. Let's say the string AB
0.67 FCT. How the shape,
and if I write W again, it will be AB. How will you match this? For this, you need a context-sensitive language. So you are saying by taking several copies, we'll take first and then pop others and compare one by one. So, okay, Kundan. So I understood your point, but even if you take several copies, how many copies you will need? There will be infinite number of copies that you will be requiring. How much length is to be compared? Because it is a W and it is a W. So here we have W and W, right? It is not reverse of that. So by using stack, you can check the reverse of W. You cannot check the front, right? So for example, if you put the string is A, B, B, so it goes into the stack like this, A, B, B, right? You cannot check A first. You can only check B first. You can check the reverse. You cannot check it like this. Does it answer your question, Kundan? Okay. So, yeah. Okay. So now I think a few people are only giving the answers. I could get the answers from Kundan. So yeah, yes, Kundan. Yeah. Okay. Perfectly fine. So let me check. Is the sound problem resolved now? Are you still getting the interference? So right, is the sound problem resolved? Yes, I think Kundan says yes, and Saranya also says yes. Perfectly fine. So now, guys, what I'll do right now is briefly tell you the theory behind the same, and then so that you are able to solve the things. Right? Okay. Is it okay, guys? Sound and all, everything is fine, so that I know that you all are there. Right? Just a second. Okay. So let's discuss the theory briefly, and then we will start with the with further questions on the identifying the type of the language. So let's see the first one. So I have just defined the languages, the types of the languages in this table. So if you see this table, so we have some 4 types of languages. We have regular languages, we have context-free language, we have context-sensitive language, and we have recursive enumerable language too, right? Yes, Abhilash, thank you for confirming, right? So now we have some 4 types of languages with us, and for these, each of these languages, we have a generator of the grammar also, right? So for example, the generator of the grammar will be, so the grammar generates the language. For example, what we have is, first of all, we have the language, and after that we have the generator of that language, that is called the grammar. So for each language we have a grammar. For example, for regular language we have regular grammar. For context-free language we have context-free grammar. For context-sensitive language we have context-sensitive grammar. And for recursive enumerable language we have recursive unrestricted grammar. So we call it as unrestricted grammar, right? So once I discuss this theory, you'll be able to answer, all of you all will be able to answer it correctly, all the questions, right? So I'll briefly discuss in another 5 to 10 minutes, I'll discuss this, and then we will further do more questions, right? So similarly, these grammars have been classified by the Chomsky hierarchy, wherein they are called as type 3 grammars, type 2 grammars, type 1 grammar, and type 0 grammar. So in exam, they may also ask, what are type 3 grammars? Like instead of giving the name as a regular grammar or a context-free grammar or a context-sensitive grammar, they may also call it as type 3, type 2, and type 1 or type 0 grammar. Is it okay? Yeah? Okay. So, and further, once we have the language generator, we need language acceptors too, which are going to accept the language, right? So till this, we had discussed the grammar generator, and then we discussed the language acceptors. So these are the language generators, and these are the language acceptors. Jaise finite automata accepts regular languages, then push down automata accepts context-free languages, linear bounded automata accepts context sensitive languages, then Turing machine accepts recursive enumerable languages. Is it okay? Okay, so Kundan, I'll get back to you. Let me just complete this slide. We'll get back to your question again. Right. So in general, the hierarchy of the languages is like that the regular languages are a subset of context-free language, context-free is a subset of context-sensitive language, and context-sensitive is a subset of recursive enumerable language. Is it okay? Okay. Is it not visible, Samtip? Am I not visible? Samtip says I'm not visible. Am I visible now? Can somebody confirm? Visible. Okay, thank you, Saurav. Thank you. So let us get back. Sometime maybe just you refresh your browser. You'll be able to see. Others are able to visualize me. Right, Kundan. I'll get back to your question again. You say in that question, I think WXW AB plus is non-deterministic CFL. Please, sir, one check. Okay, on WXW you want me to check, on AB plus. I'll do that. I'll do that for you, Kundan. But let me complete this slide first. So what I'm trying to say is languages are regular, context-free, or context-sensitive, recursive, enumerable. They form a hierarchy. That means, so regular languages are a subset of context-free languages. Context-free languages are a subset of context-sensitive languages, and context-sensitive languages are a subset of recursive enumerable languages. So something which is regular is also going to be recursive enumerable. Is it okay? Right? So this hierarchy should be there in your mind when you are answering the questions on identifying the type of the language. Is it okay? Yes. So let's go back to Kundan's question, who asks, I'll go back to Kundan's question again. So Kundan, which option you have the doubt in L3 you have the doubt, right? In so L3 says WXW AB plus. Yes, again, I think you are asking the same question. When you are saying non-deterministic CFL, there you do not know what is the length of the string. So for checking W with W, you will require functionality of a queue which is not available with the push down automata. Therefore, we cannot say it is a context-free language. Are you getting my point? Because you have to compare W with W. When you are pushing W on the stack, then you are getting the reverse of W while checking. So you cannot say that I'll be able to do it with using a context-free language, right? Yeah. So let's move further. Right. So now when a language is given to you, how you are going to identify the type of that language, I'm giving you some brief hints. Using that you can solve these questions, and this is what is going to lay the foundations of the next 6 or 7 questions which we are going to discuss. So those who do not know these concepts can learn from here, or those who have already learned, they can just brush up these concepts when I'm discussing this, right? So let us see, when do we say a language is regular? So first of all, it has to be accepted by the finite automata. So when I say accepted by the finite automata, mind you that what we are trying to say is that strings in the language should be accepted by the automata. Strings not in the language should not be accepted by the automata, right? No, Kundan, it is not starting and ending with the same symbol. As I took the example, Kundan, I'll get back to you on this question again. Let me briefly define this. Again, if you look at the language, it is not starting and ending with the same symbol, since it is W. I took the example also, right? Yeah. So maybe I'll just give you the example once again, Kundan. So when I say one of the strings is AB and other in between I write A plus B star, W will be AB. It is not starting and ending with the same symbol, right? If it would have been WX, WR, then you could have said what you are saying currently, right, Kundan? Okay, good, right. So now let's go back to what we were discussing now, was the finite automata. So now what is finite automata? We all know how to draw the finite automata and all. In general, if somebody doesn't know, we will discuss in tomorrow's class. The remaining topics in theory of computation, I'll be talking about these topics in the next series of the lecture, which is happening tomorrow, right? So let's see, finite automata is one thing. If you are able to draw the finite automata for the language, you can say that the language is going to be a regular language. Now, if the language is finite, then you can always say that the language is regular. For example, if I say set of all strings of length 2,
my dear,
strings of length 2, I will say that the language is regular. Similarly, if I say a to the power p, where p is a prime, and p is less than equals to 1. In this case also I have made the language finite, therefore it is also going to be a finite language. Is it okay? So this is the second point which we will keep in mind. Then, if the language is infinite, what you have to check? If the language is infinite, in this case you have to check two things. In this case you have to ensure that the pattern that you have in the language is a finite pattern. Pattern is in AP. That is in arithmetic progression. So for example, if we see this, a to the power n is a regular language, a to the power 2n is a regular language, but a to the power n square is not a regular language because the pattern here is not in AP. So pattern among the strings, right? Is it okay? And now when I talk about another infinite language, and so infinite languages which require no memory,
my dear student, as no complete material, the failure is sudden.
Finite memory or finite comparison, are also regular languages. And these all are regular languages. So for example, if I give you the string called, say, a to the power n, b to the power m, usually, so here n and m are independent of each other. Although the language is infinite, we can still make a finite automata for it, right? But in case I give you a to the power n, b to the power n, in this case you do not have anything to check the n with this n. So here you need an infinite comparison. Therefore, you cannot say that this language is regular. Is it okay? So these are the hints which will help you in finding out, in checking out whether the language is a regular language or it is not a regular language, right? Okay, Saranya, some interruptions. Is it like in what way? You are not, the voice is breaking. What is happening? Just maybe you just let me know what exactly is the issue so that I can ask the technical team to resolve the issue. So other lectures sound sometimes. Okay. Okay. So okay, Kundan. So they are checking. The team is checking that what about this issue. Will soon resolve this issue. But otherwise, are you able to hear me properly? That interruption is a big interruption. Are you able to hear me, or that interruption is bothering you a lot? Okay, you guys can hear me. Right, Kundan. Thank you. Okay, so so the team is resolving that, and I think we will parallelly we'll check that how to let them resolve, and we'll keep on studying for the time. Right. So this is all about the regular languages, how to identify that the language is regular. Now, when you are talking about the context-free languages and the context-sensitive languages, here when I talk about the context-free languages, it also accepts infinite languages. But the thing is, no more than one comparison should be done at a time. No more than one comparisons should be done at a time. Should be done at a time. Yeah, just a second. So yes, guys, so the team is saying they're resolving the issue, but in general, you should not be worried a lot about it. If that is really troubling you, then you'd be able to resolve. We'll resolve this immediately, right? But at least you should be able to understand what I'm saying. If you are not able to hear me properly, then let me know. Otherwise, they are resolving the issue, right? So now, what I told is, if the language is infinite but no more than one comparisons are there, then definitely we can say that the language is context free. So for example, a to the power n, b to the power n is fine, but when I do a to the power n, b to the power n, c to the power n, I cannot say that this language is regular. Why I cannot say this language is context free? So this is context free, this is not context free. Why? We are doing more than one comparison. So we are doing two comparisons over here. So we are comparing this n with this n and this n with this n. This is not allowed in a context-free language, right? Similarly, another thing that you have to notice is that you are only using a stack. So for example, so you are using a stack in a push-down automata. So therefore, WW can be accepted, WWR can be accepted, but WW cannot be accepted by this. WW cannot be accepted by this. Yes, Kundan. It is, if it is more than one comparisons at a time, then it becomes a CSL, right? Non-linear power is also CSL. Correct, Kundan. But even for example, let me give you one more example which says that, which is again a context-free language. Say for example, a to the power n, b to the power n, c to the power m, d to the power m. This is a context-free language. Over here, although you are doing two comparisons, but they are being done individually. First you are doing this comparison, then you are doing this comparison. Is it okay, Kundan? Right? Right? Okay. Okay, perfectly fine. So, okay, right. So now we have this a to the power n, b to the power n is done. Then we have also done with the stack. So always remember, you have a stack, you do not have a queue, therefore you cannot accept WW. Even Kundan, this answers to your question that you were asking previously in the previous question which I showed, right? So WW cannot be accepted by the context-free languages, right? Let's start with the context-sensitive language. When we are talking about a context-sensitive language, now over here, what you have to understand, it gives you the power of a queue, right? It is called a linear bounded automata, where the size of the tape, so for, although it is basically a Turing machine, where the size of the tape is fixed to the size of the input. So in this case, it becomes a linear bounded automata. So whatever is accepted by the linear bounded automata is called as a context sensitive language. So in this, everything is accepted. Like for example, whatever was the problem there, it is in context-free languages, we can resolve it here. For example, WW is resolved here. Similarly, you can also resolve w to the power n also can also be resolved. Similarly, the language a to the power n, b to the power n, c to the power n is also resolved here. So there is no issue regarding these languages. Okay, so there is no issue regarding these languages here. I think, yeah, is it okay? Right. So now let's get back so this is all about the entire gamut of languages that we have. So we discussed how to identify a regular language, how to identify a context-free language, how to identify a context-sensitive languages. And now I'm sure you all are prepared with how to solve the identification of language questions. Now I'll give you some 6-7 more questions, and based on that you will be able to solve all the questions in the GATE exam, right? So let us see that. So Krishan has a doubt. Your doubt. So Krishan, can you type again? It went above. Yes, Kundan. Yeah. So your doubt again. We'll check that. I don't know. Just let me check. So maybe can you tell? So right. So Krishan, can you type your doubt again? It went above in the chat. I can't see it again. So briefly, I've talked about what are regular languages, how to identify the regular language. We have also studied what are context-free languages, and we have also talked about what are context-sensitive languages, and this is how you are going to identify also. I have discussed in detail. Right, now let us see more questions. So Krishan, your doubt is a to the power n, b to the power m, c to the power n, d to the power m. No, Kundan, we cannot do it. So again, so you a nice question. So I'll just make some space here for your doubt. So you say a to the power n, b to the power m, a to the power n, b to the power m, then you have c to the power n, then d to the power m. Again, you cannot check it using a stack. So first of all, you pushed n a's. So first of all, you pushed a's. So okay, so you have pushed a's, but once you push a's, then you push b's. But when you arrive here at c, you need to check c's with the a's, which are down in the stack. So therefore, you cannot do it, right? So this is a context-sensitive language, right? Kundan, you are right. This is a context-sensitive language. Using a stack, we cannot do it. So the first point which I said is, you have to accept it using a push-down automata, or you can also draw a and which has a stack in it, right? So this is all about this. This is all about the context, the identifying the type of the languages. Cross matching in reverse is CSL. Yes, of course. When you have WWR, Kundan, then you can do it, right? Okay. So now let us see the next question that we have for you. So again, this is an MSQ question, as the trend is these days is MSQs. I have made more and more MSQs questions for you guys. So I will give you some 2 minutes to solve this question. Yeah. Yeah. So you have 2 minutes to solve this question, then I'll solve it for you guys. So yes, Gagan, you are correct. Kundan, you are also correct. Abhilash and Saurabh, all of you are correct. Any other answers? I'll just wait for 20 more seconds for other answers and then I'll explain it for you guys. Yes. So now let me explain it to you. So now you see, we have asked that which of the following languages are regular, right? So when you are asking sir the questions on W, X, W and such kind of questions are there where you have to, where X, W and W are A and B and X is also the same, there you have to see the worst case while solving these examples. When I say the worst case, you try to see whether you are able to eat up the entire string or not using X so that you don't have to do the comparison. So W and WR requires a comparison in the reverse order. What do spatial symbols actually mean? Yes, Gagan, I'll get back to you on this. Let me explain it step by step, right? The answer is A and C. Let us cross check. So A and C are the answer, right? So when I say WX, WR, so when you are solving these kinds of questions, always remember, first of all, you have to look out for the cases which are extreme cases. When I say extreme cases, you have to reduce the number of comparison to the smallest amount possible. That is one thing that you have to do, right? AC is regular, BD is CFL. Yes, Abhilash, you are correct. We'll cross check this. We are doing it, right? So now in this case, when X eats up this entire thing, W and WR can be epsilon. So for example, it is given as WX, WR. Now I keep W as epsilon, WR as epsilon, and my X becomes A plus B star, which is a regular language. It is a regular language, right? Now this language, now there might be strings in which W and WR are not epsilon, but in that case also, my A plus B star covers everything. So my worst case which I have taken, which will eat up the entire string, will cover all those strings also. So the union of the language is basically what? Sigma star. So if the union of the language is sigma star, I don't need to consider other cases. So if the worst case encompasses all the things, then you can say that your language is regular. So if the worst case encompasses everything, then only we can say this, right? So always keep in mind two things. Think about the worst case, and it should also, you should consider the union of the languages, right? These are the two things that you have to think while solving such types of questions, right? So now this is a regular language as we just discussed. Now Gagan had a question that WCWR, why do we say, what is a C? Why, when we say C is a spatial symbol, what do we mean? So Gagan, it is a different symbol. For example, A and B are two symbols. Now C is a different symbol. So my sigma is ABC, where W and WR are only taking AB, are taking A and B, and C is a different symbol. So it's a spatial symbol which is not being used by W and WR. Is it okay, Gagan? You got the point? Yes. So, right. So when I have something called WCWR over here, I cannot eat up the entire thing. I will have to compare W and WR. Therefore, it becomes a context-free language, and also as Gagan. And even Abhilash also said that it is a DCFL, perfect. B and D are CFL. Abhilash, I can also say this is also going to be a deterministic context-free language, right? Because yes, perfectly fine. Yes, it is that, and it is a deterministic context-free language because when C comes, I get to know I can start popping up the string. So I deterministically know how to pop up the string. So guys, those who do not know deterministic and deterministic context-free languages and context-free languages, when I say deterministic context-free, I should be able to draw a deterministic push-down automata for the same. When I say context-free languages, I might not be able to draw the deterministic context-free automata. So every DCFL is a CFL, but every CFL is not DCFL, because in case you are able to draw a non-deterministic automata, in that case we cannot say so, right? Is it okay? Right. So next we have WXWR, where W comma X goes to A comma B plus. In this case, again, although W cannot eat up the entire, X cannot eat up the entire thing. It will only leave two letters, one in W and one in WR. So for example, this is WX WR. You have WX WR. So now your WR becomes epsilon, cannot become epsilon. It is at least a one length string. So what are the two possibilities? So what are the two possibilities that we have? We can either keep W as A, WR will also be A, then this can become A plus B star. Similarly, we can also have B, A plus B star B. So this is the regular expression for this. Therefore, I can say that language C is also a regular language. So that when I said A and C are the correct answers. Right? Are you getting this point? Perfect. So now we also have WCWR.
What is
A, where W belongs to A comma B plus and C is a special symbol. It's exactly similar to what we discussed in B, right? This is exactly similar to what we have discussed in B. Therefore, this is again a deterministic context free language. Therefore, the answer will be, this is regular, this is deterministic context free, this is also regular. So therefore, the answer comes out to be A and C. Is it okay, guys? Yeah. Yeah, sir. Yeah. So he says, Kundan says B is an odd palindrome. Yes, of course it is.
better?
So, for example, W is A, B, B. You have C, then B, B, A. So it's an odd palindrome. Definitely, it will be going to be an odd palindrome because W and W are going to have the same length, and C is going to add. So these two will make it even. C will make it odd. Right, you are correct, Kundan. But you answer only two symbol. I didn't get your doubt properly, Shatrughan. Can you explain your doubt in proper way? See in option 3 symbol, but you answer only two symbol. I didn't get your doubt properly. Maybe can you write it properly? Right? One. Okay. So by the meantime, we'll move to the next question. So here is the question for you guys. Which of the following languages is or are context free? And I'll reset the timer. And I'll give you 2 minutes to solve this question. Yeah. So Gagan says ABD, Abhilash says ABD, Kundan says AB. Just cross check once. Kundan also says ABD now. Others, what is your answer? Well, we have. So we will wait for 20 more seconds for some other answers. So Gagan, you are correct. Nikhil, you are correct. Abhilash, you are also correct. Kundan, you are also correct. Others, please comment your answers. Okay, so that's it. We will solve the question now. So now we have which of the following languages is or are context free. This is the question. We want to say find out the context free languages out of it, right? So so guys, can you also tell Abhilash, Kundan and Saurav or Gagan who also solved this question, what is the most limiting language which accepts it? So what is the most limiting case of these languages? So right, so just tell me what is exactly this language is. So for example, when I say context free, whether like regular languages can also accept it or not, just tell me the most limiting case to me, right? Yes, you guys are answering it correctly to some extent. We'll see the answers now. Just also try to find out the most limiting cases, right? So now we have L1 as XWW, where W comma X goes to A plus B star. Over here again also what I can do is I can take W and W as epsilons, X as A plus B star. So this becomes a regular language. So every regular language is also a context free language also. Therefore option A is correct. Is it okay guys? So this is a regular language. This is a regular language, right? Yes Gagan, you are correct. Let us cross check. Let us cross check. Yes, so Gagan says A and B are regular, D is NCFL. Abhilash says A and B are regular and D is CFL. Let us cross check, right? Okay, so when Abhilash says CFL, it is non-deterministic CFL, and as far as I see, right? Okay, so let us cross check guys. So again, similarly over here also I can take W and WR as epsilons, then XWWR, X can be taken as A plus B star. This is also a regular language, right? So if it is a regular language, it is also a context free language. I can simply say this, right? So A and B are correct. Now when I have L3 as XWW, here X cannot eat up the entire string because at least the length has to be 1 for each of the symbols. So XWW, so we have to compare this W with this W. In this case, the language comes out to be a context sensitive language. X cannot eat up the entire thing. Even if it eats up, it will be only left with the last two symbols, and I cannot write a regular expression for the same. Therefore, it is a context sensitive language. Therefore, it is not the part of the answer, right? And similarly, the last case says L4 is equals to XWWR. Again, X cannot eat up the entire string over here, but I can compare W and WR using a context free language. Therefore, I will say that it is a context free language because W and WR can be compared using a stack functionality, right? So therefore, I can say that D is also context free. And when you guys said it non-deterministic context free, you are perfectly right because there is no special symbol to tell us that when W starts and when WR is going to start, right? It is definitely a NCFL, right? Okay. So let's move to the next question that we have. Sorry, just a second. So we have discussed this. Yeah. So this is the next question that we have, and I'll again reset the timer to 2 minutes for you guys to solve this. Yeah.
A slab
So any answers for this question? So what is the final answer? None of you have answered the final answer. So Gagan says all of them are deterministic. So I kept the mic on mute. Yeah. So I think Gagan, your answer is incorrect. Kundan, your answer is also incorrect. Abhilash, yours is also incorrect. Yeah. So just think once. I'll answer it in one more minute. Yeah. Just try it once. Yes. Yes, Kundan. I'm waiting for your answer. You can just try to solve it once again. Kundan says A. Now Kundan is on the right path. Just check other options, Kundan too. Kundan, check other options too. Sorry. Yeah. Last 30 seconds and then I'll explain it to you guys. Now Kundan, you have solved it correctly. Correct. What about Gagan and Abhilash? Just try it once. Yes, Abhilash, you're also correct. Now we'll solve it. Gagan, what about you? Are you able to solve? Yes, Gagan, you are also correct. Saurabh, a bit of a problem in your answer. Okay, now let us solve it together. So now we have L1 as WXWY, where WXY belongs to A plus comma B plus, right? Now over here, let us see whether, so over here it is very clear that we want to compare W with W, rest anything, everything is fine, the rest everything becomes regular. right? Now let us see whether x and y can eat up everything or not. If we are able to check that, then in that case it can become a regular language too, right? So let's see that. So wx, wy. Now if x eats up this entire string, we are only left with one pointer here, one letter here, and y, if it eats up the entire string, then we are only left with one letter over here. So at the end of the day, we are only comparing the first letter with the first letter in W. So this way it becomes a regular language. We can write a regular expression too. What is the regular expression? The regular expression comes out to be A plus B star, A plus B star. Or W can also be B, A plus B star, B, A plus B star, right? So in our worst case, we could write a regular expression, and all other cases in which W can also be two length, this W can also be two length. If two letters are matching, one will also match. That case is encompassed by this case. Therefore, I can say it is a regular language. Since it is a regular language, it is also a deterministic context-free language also, right? So therefore, we can say that this is a regular language. Therefore, it is a deterministic context-free language too, right? Right? Guys, could you understand why it is regular? Could you understand why it is regular? So, I'll just take it on the next page. Just a second. Oh, yeah. I'll paste it here. Sir, yes. So I think we solved the first part. Could you understand why it is regular? Is it okay? There will be plus. Yes, yes, Kundan, you are correct. There should be a plus there. I'll correct it. It should be a plus over here. Correct. You are correct in that sense. Just a second. It should be a plus over here. You are perfectly right. It should be a plus over here. Right. Is it okay now? Clean plus. Correct. You are correct. Kundan and Saranya, you are both are correct. Right. Now let's see the next part. The next part says x, w, y, w. W comma x goes to a comma b plus. Again the same thing over here also. You have x, w, y, w, where w comma x is going to a comma b plus. That means x can eat up this entire w, but only one letter will be left, which is the last letter over here. Similarly, y can eat up this entire thing. It will only leave the last letter over here. And in that case, I can write two combinations. The way I wrote it earlier, I will write it as A plus B star, not star but plus, A plus B plus, then I write an A, then it will be A plus B plus, then it will be a plus A plus B plus B, A plus B plus B. So this becomes the regular expression for the second language. Therefore, if a language is regular, we can also say that it is also a context-free language also, right? It is a deterministic context-free language because regular languages are a subset of deterministic context-free languages. Is it okay till this point? Right? Now let us understand L3 and L4. Let us understand L3 and L4. Let us understand L3 and L4 now.
But
Cut. Where is paste? Yeah. So now let's see L3 and L4 now. So L3 is X WX. Sorry, just a second. Yes. So L3 is, okay, just a second. Yeah. So L3 is WXYW. WXYW. Now over here, let's see whether W can, X and Y can eat up the entire thing or not. Here, if you see, if X eats up the entire thing, it will be left with the first letter. And here, if Y eats up the entire thing, it will be left with the last letter. And since this is the scenario, we cannot write the regular expression here. Because if you think about writing the regular expression where you're only comparing the first and last letter, there are languages in which W will be AB. This W is also AB. XY can be A plus B plus. Now Y can also be A plus B plus. In this case, the first letter is not matching with the last letter. Even then, this belongs to the language. And we are, as we defined, that the language definition is that the, so for example, the definition is the strings in the language should be accepted and the strings not in the language should not be accepted. So if I write this regular expression, which is only comparing the first and last letter, we cannot say that that regular expression is going to represent this language. Is it okay? So since I cannot write a regular expression, I will have to at the end of it compare both W's, which makes it a context sensitive language. Is it okay, guys? Yeah, thank you, Ankit. Thank you. Yeah. So the last case is XWWY. Over here also the same problem will come. This X will eat up the entire W, but the last letter. This Y will eat up this entire W, but the first letter. And I cannot simply say that just compare the last letter with the first letter, because there are which have more than this, right? So for example, this W is AB. Now this A is not matching with this B. If X eats up this, Y eats up this, right? Are you getting the point? Right? Yes, okay. So I think everybody understands this. Let's move to the next question. So guys, are you getting the flavor of the kind of questions, how they can be made complex by doing this? They will just add more symbols and they will give it more power to those symbols, and then you have to just check whether that can eat up the entire string or not, whether that comparison can be reduced, whether you can make it regular or not. And always take care that when you are doing that, the bigger picture should be a subset of that part. So for example, you have took the one length, so when I say that when you took the worst case, that worst case should be able to encompass all other cases. In this case, we could not do so. Therefore, we had to say that it is a context sensitive language, right? I hope everything is clear till this point. If you have doubts, you can keep on writing in the chat box, right? Now let's see next example. Which of the following languages is or are considered tree? where R is the reversal operation. I will give you again 2 minutes to solve this question. Sure, I'll cross check. Yes, Kundan. Your answer is incorrect. Your answer is incorrect. And as I say that this question, option C, this option was asked in one of the GATE examinations, and it was a SIP version. Just think about option C and D once again. Yeah. So the question which came in GATE was simpler than this. I have made it a bit more complex. Just try to think about it. Kundan, you are incorrect. Just cross check once again. Abhilash, you cross check once again. A, B, C, Gagan, you are incorrect. Just check. So it's already 2.5 minutes. Just 20 more seconds for you guys to answer it correctly. Yeah. Kundan says BD. Saranya says BC. Everybody is incorrect. Kundan BC. Okay. It's still incorrect, Kundan.
Cover.
It's still incorrect. BCD. Yes, now you are correct, Kundan. Correct. So BCD is the right answer. Gagan, I'll give you just 30 more seconds to think about why it is so. The correct answer is BCD. Kundan has answered it correctly. So I think Abhilash, Kundan, and I think Gagan and Saurabh, Saranya, just try to think once why it is so, and then I'll answer it for you guys. Stop the timer. Gagan and Abhilash, are you able to come up with the answers? Okay, I'll explain Abhilash that. What about Gagan? Where do you stand? Like, what is your final answer now? 8 is CFL. CFL is not closed under complement. Okay. So okay, I'll answer your question briefly, Abhilash. Just a second. Others have answers B, C. A can be regular, right? A cannot be regular, Gagan. Okay, so now let me explain it. Enough of the time that I've given to you guys. Now let me explain it properly. Abhilash, I'll answer to your question shortly. What you have asked is correct, but yeah, I'll answer it. Language is given. We have to check it because it is CSL, can be CFL or regular also. Okay, I'll come back to your question. I'll answer it properly. So let me do it one by one. So now over here we have L1 as WW. Again, Gagan, I think you cannot do any eating up business over here. W and W are two other strings. You cannot eat up everything, right? So you have to compare W with another W, one by W with another W. You cannot do that. You cannot eat up the things. Therefore, W has to be compared with W, and for that you will require a context sensitive language. So it's a context sensitive language. So Gagan, I think doing out complex questions, you made a mistake in simpler questions, right? So don't do that. It's a simpler one. So I set up it like that I gave many complex questions and then I gave a simpler one, and then you ended up doing it wrong, right? So don't miss the basics, right? So eating up business only happens when there are different symbols, W, X and W. Over here, nothing, no one can eat anything. So W and W have to be compared, which requires a context sensitive language, right? Gagan, is it okay? Right? Yeah. So then we come up with WWR. Over here, we all know it's a context free language. So therefore, option B is correct. Now the point is why the complement of L1 and why the complement of L2, why I'm saying that they are context free, right? So let us see one by one. When I say the complement of L1, over here I am saying that what is L1? L1 says W and W should match where each of them can go to A plus B star. Is it okay, guys? Each of them can go to A plus B star, right? Now, when I say the complement of L1, I have to ensure that this W should not match with this W. Is it okay? So when I say this W should not match with this W, what I can do it, I can make this W as epsilon and this W as A plus B star. And I know that A plus B star is a regular language. And this encompasses everything. Which when I told that when you are doing this eating up business, always ensure that whether you are encompassing everything or not, is there a case which is left, right? So one case is left when this W is epsilon, this W is also epsilon. In this case, I cannot say anything. In this case, both will become equal. So this case has to be removed. So A plus B star minus epsilon will become as A plus B plus, and A plus B plus is a regular language. Therefore, it is also context free. Therefore, L3 is also correct. Are you guys getting this? So Abhilash, when you say A is a CFL, so you were talking about option D. I am coming to that option. So that Abhilash is a generalization. In general, they are not closed when we say, but given specific, when we say that CFLs are not closed under complement, you are perfectly fine when you are saying it, right? But specific cases have to be checked. When the case has been given to you, you check that. So when we make the tables and we say that CFLs are not closed under complement, intersection or set difference, these are the things, this is for all the context free languages. Some of the context free languages may be closed, right? If the question specifically gives you the language, check that language. Do not simply answer it based on the knowledge of your table. The closure properties table I am talking about. Abhilash, could you get my point? Right? So let me explain it in a bit more detail. You will get it in a better way. So in this case, complement of L2. So over here, what I want is the reverse should not happen. The reverse should not happen. The complement of it, I'll take it as epsilon, I will take it as a plus b star, and I will also remove that epsilon case. When both of them are epsilon, it will eventually become a plus b plus, which is a regular language. If it is regular, it is also context free. I can say that our answer is B, C and D. The answer is B, C and D. Okay, so the tables are to be used for generalization. When the language is given to you, you have to look at the language and then think whether it is regular or not. Is it okay? All good? Okay, Gagan, what is your situation? Are you got the answer? Language is given. Okay, that's answered. Yeah, so Gagan, Abhilash and Kundan all on the same page now. Should we move ahead? So let's do one more question now. So once we complete this identification of the type of the language, we'll move to the closure properties and also to the decidability and undecidability. Those who do not know it, don't worry guys, I'll briefly discuss the theory also so that you will be able to answer all the questions. Don't worry guys. Okay, so let's go to the next question.
Okay.
Here is the question. So I've given you some languages and you have to tell me, consider the following languages, how many of these languages are deterministic context free. So this is a NAT based question. I'll give you 2 minutes to solve this. Yes, okay, Gagan, Abhilash and Kundan all are on the same page. Good guys. So just solve this question.
Yes, fine.
Any answers guys? Gagan, you're incorrect. 5 is incorrect. Kundan, you're also incorrect. Just try it once. I'll give you 1 more minute to solve it, as 3 minutes is the usual time for a question in GATE exam. Like slightly less than 3. I'll give you just 1 more minute to cross check it. All of you are wrong. So we have to check whether it is deterministic context free. It's not context free. Deterministic context free you have to check. How come L3 become a deterministic context free language? I don't understand. Kundan says 3. 3 is the number. Okay. What else? Others? What is their answer? Total 3. Yes, Kundan, your answer is, Kundan, you are correct. Perfectly fine. And you say that L1, L2, L5, these are the languages which are 1, 2 and 5. Perfectly fine. Yes, 1, 2 and 5 are the languages which are deterministic context free. Perfectly fine. So can you say what is the strictest class for these languages, L1, L2, L5? What is the strictest class? They are deterministic context free, or do they have a stricter class? I'll stop the timer. Do these languages have a stricter class? Kundan says DCFL, DCFL and DCFL. Kundan, I think mistake is there. It's not. Gagan, you are correct. Fifth is a regular language. Perfectly fine. What about L1 and L2? What is the stricter class for them? What about what is the stricter class for L1 and L2? One and two are DCFLs and 5 is regular. Abhilash, you are perfectly correct. So let's see the answer now. A to the power n, B to the power n, C to the power m. Again, we have to just compare A and B's, and we can deterministically tell the push down automata when A comes, you push in, when B comes, you push pop out. Therefore, we can say that L1 is a deterministic context free language. Perfect. So, and Gagan, yes, your answer is correct. Fifth language is the regular language. Yes, you are correct. Let us see. A to the power m, B to the power n, C to the power n. Again, the same thing. We are only compare n's with B, number of B's with number of C's. I can again say it is a DCFL. These two are perfectly correct. Now, when I say L3 is L1 union L2, over here either A's are equals to B or B's are equals to C. I will have to make a non-deterministic push down automata for it. Therefore, it is not deterministic context free, it is non-deterministic context free. Is it okay? Yes? It is a non-deterministic context free language. Kundan says L4 is CSL. Let's check. Yes, definitely Kundan, it is a CSL language. It is A to the power n, B to the power n, C to the power n, and I discussed when I discussed the theory, it is a context sensitive language. Therefore, this is not counted. L3 is not counted, L4 is not counted, L1 is counted, L2 is counted. Is it okay? Is it okay? Yeah. Now let's move to L5. Let me make a copy of this because otherwise this is the screen is full. Let me make a copy. Where is screenshot will take? I'll take this to the next screen so that I can write properly. So 3 is the answer. You guys were correct when you said that. So we are left with L5, L6 and L7. We are left with L5, L6 and L7, right? So let's see. Just a second. Let me check. Just a second. I'll paste it again. Just a second. I'll paste it again. Somehow it got interrupted. Just a second, guys. Yes, now it's fine. Right. So now let's see. When I say L5 and L6, L5 is A to the power n. L5 is A to the power n. L5 is A to the power n, W A to the power n. Over here, guys, again, n is greater than or equals to 0. Let us make n equals to 0. In this case, W can become A plus B star. W can become A plus B star. Again, this comes out to be a regular language. Now somebody can ask, who told you it is going to be 0 only? It can be other things also. Yes, definitely it can be. It can be AA, W, AA, but that is also encompassed in A plus B star. So therefore, you should understand clearly when I said the word encompass, that has a lot of meaning. When I say encompass, the worst case that you make should be able to encompass all other cases. Therefore, we can say that it is regular. Are you getting this? So this is a regular language. This is a regular language. Now, L6. Over here, we have to compare the number of A's with number of B's and number of and W with WR, right? That's the situation. Now, when I put W in the stack, then I put A on the stack, then I have again W, which is to be WR is to be checked with W. Now, it is at the bottom of the stack. It is taken by A. So therefore, it is not context free. It is a context sensitive language, right? So again, always remember that has to be accepted by the stack. By using stack, we should be able to accept that language, right? When I said push down context free languages, I clearly said that you have to use the push down automata, right? So sixth is CSL, correct. You are correct, Abhilash. I explained the same right now. And when you say this language, this is a context free language, how you post W in the stack, you push W in the stack, then you push A in the stack, all the A's, then you match B's with A's, then you check W with WR. So this can be done using a stack. Therefore, we can say that L6 and L7 are CSL and CFLs respectively. Yes, but it is not going to be a deterministic context free one, because you cannot definitely tell that when are you going to pop out for this W. When are you going to pop out for this W? Therefore, it is not a deterministic context free. It is just a context free language. It is NCFL. Yes, Kundan, you are correct. All right, everybody is okay till this point? All right. Yes, Gagan, Kundan and Abhilash, are you getting these points? Yes, right, Kundan. Right. Fine. So let's move to the next question. Yes, which of the following languages is or are context free? I think this is a very simple question which all of you should be able to answer it now. I expect everybody should answer it properly and in the right way. Take your 2 minutes and let's see how many of you could answer correctly. Correctly, perfectly fine. And this seems to be the simplest question on identifying the type of the language that we have done, right? So, okay. So let's see the solution. I'll stop the timer now. Okay. So when I say which of the following languages is or are context free, again, let's start from the bottom. WX, XR, WR. Over here, we will simply push W first, then X, Now you will check X with XR and then WR with W. So this can be done using a stack. It is a context-free language. Mind you, it's a context-free, it's not deterministic context-free. Everybody understands this point? It's not deterministic context-free, it's a context-free language, right? Because we do not know when to push and when to pop, we have to do it non-deterministically, right? Now, same over here. Over here, what is the strictest class for this language, guys? For C, what is the strictest class? Although it is context-free, what is the strictest class for this language? Any answers? So what is the strictest class for this language? It's a regular language, right, Gagan? Why? Because X might eat up the entire string and W and WR remains epsilon. So therefore A plus B star is the language, and A plus B star is the language which is a regular language. So if it is a regular, it is a context-free language also. C is correct, D is correct. Now let's talk this. Again the same thing you can do over here. W, WR, W you push W, you pop WR. So when you are doing WR, you pop W. So then you push X. This is gone, X and XR can be compared using the stack functionality. Therefore, it is also a regular, it's also a context-free language. Again, mind you, it's not deterministic context-free, it's a context-free language, right? C is regular. Yes, Abhilash, it's fine. And then at the last, X, WX, WR, XR, over here, the stack business will not work. You first push W, then you push X, then WR, then XR. You cannot compare W with W because X has come up on the top of the stack. So therefore the answer is B, C and D. Right? Right? So this was the simplest question that we did today, and believe me, the questions will be simpler than the questions that we have done today, and this was the simplest one. The questions will be of the will be of this type in GATE. We have done more tougher questions, right? Now let's see the last one on the identifying the type of the language. Then we'll start the next topic. The last question on identifying the type of the language. And I will give you just 2 minutes to solve this question. So again, this is also an MSQ based question, right? I've taken most of the questions in MSQs and NAT only because that's the current trend. Kundan says B, C, D. Gagan says C, D. Okay. What about Abhilash? Gagan, you are incorrect. Kundan, you are correct. We'll just wait for 30 more seconds for your answer. We'll just wait for 30 more seconds for your answer. Oh, Saranya is back. Yes, yes, sorry. Okay, so is it audible now, Kundan? Is it okay? So, Kundan, your answer is correct. It's B, C, D. Aditya, you are wrong. It's not B. Saranya, you are also correct. Kundan, Okay, so Abhilash says CFL, CSL and recursive, perfectly fine. Oh yes, B also, yes, definitely. So it has to be B, C, D. It is B, C, D. Now let me explain it to you. This question is a bit complex one. Let me explain it step by step to you guys. Okay? So we'll go step by step. If something is unclear, please interrupt me in between. Let me explain it properly to you guys. Right? So guys, see, what is given is x comma y belongs to 0, 1 star. So again, this eating up business is not here. We have to compare that the length of x and y has to be equal. And x should not be equal to y. If we think like that, someone say that x has to be compared with y. This is a functionality which is given by the context sensitive languages. They might end up answering it as it is a context sensitive language, and therefore recursive too, they will answer it as CD but not B, like the Gagan answered it, right? So how do we find out it is a context free language even though we are comparing x with y? Are you getting the question? The question is a bit different. And now we have to say that the mod of x, although the mod of x is equals to mod of y, the x should not be equal to y. But if you want to compare x with y, you require a functionality of a context sensitive language. You cannot do it with a context free one. But there is a way in which this language can be handled, which makes it a context free language. Now let us see how. Now, do you all agree that when I say a language is context free language, when I can write a context free grammar for it? Is it okay, guys? Is it okay? You can compare, yes Abhilash, you can compare the length using stack, but what about if the length is equal, what about comparing x and y? Stack length cannot take care of that. So we have to go through the grammar route, because this way you are not understanding it. Gagan, did you get my point? Stack length cannot take care of x equals to y, right? The string has to mismatch, right? And for that mismatching, we'll write a grammar for this. Are you getting my point? For that mismatching, we are trying to write a grammar for it. Let's try to see. Let's try to see. So okay, so tell me guys, if I write x and y as x as w1 some symbol, say x w2, this is my x, and say my y is v1 x v2, right? So I am going to create, so is it clear to everyone that this the length of this string will be even? It cannot be odd, because if there are two things which are matching up, then it has to be even. It cannot be odd length string. Is it okay, guys? Right? Right? It cannot be odd length string, right? So what I did is I expanded x as w1 x1 w2 and y as v1 x v2. This is what I did. Now tell me guys, right now we do not know anything about the length of these languages. No? Okay? So if I write it like this, I cannot say so this x is small x, this y is a small y, this y is a small y, right? Let me rewrite it. This y is a small y, this is v1, this is y. Now you look at this. This is one string, this is another string. I have to make the length of these strings equal. Now can I say that if I write it as w1, here w1 is equals to w2, mod of w1 is equals to mod of w2, and mod of v1 is equals to mod of v2. ठीक है? क्योंकि why I'm saying so, because I am producing it as w1 x w2. I'll produce one string here, one string here. Length of w1 and w2 will be equal. Length of v1 and v2 will be also equal. Let me write the grammar. You will get it in a more proper way. But what I am trying to do is just try to understand this point and swap v1 and w2 also. I can read this thing as v1 w2 y y v2. Now if I write this string, the length of this part will be equal to the length of this part. Is it okay, guys? Why the length is equal? Because w1 is equal to w2, v1 is equals to v2, the mod, and x and y are just one symbols, they are equal. Now mod of x will become equals to mod of y. These are capital X and y, these are small x and y's. So I have bifurcated them in this way, and what I am trying to say is the length will be equal. The property of mod of capital X equals to mod of y will be satisfied even if I exchange it. I am just exchanging it for the purpose of the length, right? Now tell me, if I write this grammar as S equals to A comma B, AB or BA. S is either AB or BA. X is either AB or BA. And say A goes to XA, just a second, XA, X, right, and my B is going to XBX, and my X goes to either. So I think since it is 0 and 1, let me make it 0 and 1 here. Just a second. What happened? Just a second, guys. Okay. Just a second, guys. Let me check. I don't want this. Okay. So now, right. So now if I write X as eraser, stroke eraser, I'll write this X as 0 and this as 1, and X can go to 0 and 1 both, right? Now you tell me, I have ensured that the length of this part will be equal to the length of this part. This can either also go to simply 0 and this can also go to simply 1. Now this A is producing my X, this A is producing my this capital X, and this Y is producing my capital Y. What I am doing is I am ensuring that at least A and B differ at one point. At least A and B differ at one point. I am ensuring this thing. Are you getting this point? What I am ensuring is I am ensuring that A and B are differing at least one point. Right? Is it okay, guys? Right? So I ensure that A and B differ at least at one point, and the length of the strings are going to be similar. Therefore, I can say that I can write a context-free grammar for it. Is this grammar context-free? What is the definition of a context-free grammar? The context-free grammar is of the form A goes to alpha, where A is a terminal, A is a non-terminal, and alpha is basically V union terminal star. So every production follows this format. Therefore, I can say that this grammar is single variable at the left hand side. Right, Kundan? You are perfectly correct in this saying this. And therefore, I could write a context-free grammar for it, and I can say that this is a context-free language. Right? Is it okay, guys? Right? So now, so again, let me explain it briefly. What I am trying to do is this A or B, A is producing capital X, B is producing capital Y, wherein this is, I am assuming this has capital X and this has capital Y. And what I am ensuring it in the first part and the second part, at least one variable is different. That was my purpose. And if that variable is different, I can produce a context-free language for it. Now, this explanation is telling you why the lengths of these parts is same. Is it okay, guys? Right? So now let's move to the next part of our discussion. Is it okay, guys? So as I said, Identification, the type, the class of the language is one of the most important topics for as far as theory of computation is concerned. Every year you will find at least 1 to 2 questions out of it. And believe me, if you solve all these 8 questions that we did today, you will definitely be able to crack the question which is going to be asked in GATE, right? It will be either of the similar toughness or maybe less toughness than this. It will not be more complex than what we discussed today, right? So now let us move to the next part of discussion, that is undecidability. I'll give you a question. Let's see how much you could answer, and based upon that I'll explain the theory a bit so that we'll solve more questions on that, right? So let's move further. I don't know what is. Let's move further. So here we have an example on basically on decidability. You guys take 2 minutes to solve this. And then I'll answer it for you guys.
Four members of uh, of
So any answers to the question? Kundan says C and D. Let's check. What about Abhilash and Gagan? So Gagan, you might be unaware about the theory. I'll discuss it briefly. You'll be able to answer also. Don't worry. Abhilash, what is your answer? Kundan, your answer is incorrect. Just try to check your answer. It's not CD. I'll stop the timer. I'll just give you 30 more seconds to solve this, and then let's see where do we stand. Yes. Yes, Abhilash, you are correct. It is B, C, D. So the answer to this question is B, C, D. Kundan, yes, you also got it correctly. It is B, C, D only. Yeah. So let us solve it. It says that given that sigma is equals to A comma B, M denotes an encoding of an automaton just a second, of an automaton which of the following language is or are not recursive, right? So which of the following languages is or are not recursive? When I say recursive, that means I'm saying that it is decidable. Which of the following languages are decidable? This is the question that is being asked, right? And M is basically an encoding of the Turing machine, of the machine, right? Now you have to tell me whether it is decidable or not. When I say M is a PDA such that LM is equals to phi, that means the emptiness problem. The emptiness problem in PDAs, not recursive means not decidable. We have to tell you not decidable. The emptiness problem in PDA is decidable. The emptiness problem in PDA is decidable, therefore A is not the correct answer. Are you getting it? Therefore A is not the correct answer, right? Now, for context-free languages, that is PDA, the completeness is not decidable, therefore B is the answer. This is completeness problem. We will discuss the summary of this, how to revise this in later, just after this question, so that you can answer the next questions properly. But in general, the completeness problem in CFLs is decidable, therefore is not decidable, therefore this is one of the answers. Now LBA. LBA is basically what? Context sensitive languages. In context sensitive languages, neither emptiness nor completeness is decidable, therefore answer is B, C, D. Is it okay? Therefore the answer is B, C, D. Is it okay, guys? Right? Now, for those who do not know the decidability concepts, I will briefly summarize how to answer these questions. What are the things that you have to keep in mind? Thereafter, you will be able to solve all the questions on decidability, right? So let us see. The answer to this question is BCD. Is it clear to everyone? So what does Kundan think? PDA is not closed in completeness. Yes, correct. And for DFC, DCF, completeness is decidable. And yeah, for deterministic context free languages, yes, for deterministic context free languages, completeness is decidable, but not for non-deterministic CFLs, right? For CFL in general, it is not decidable, but for DCFLs, it is decidable. You are perfectly correct in that, Kundan. And CSL, in CSL only membership is decidable. Yes, of course. In CSL only membership and as well as complement is decidable, Kundan. So let me summarize the things for you guys so that you can always answer it correctly, right? Let's see the brief theory behind this, and then we will discuss some 4 or 5 more questions that will also complete the decidability topic for you guys. And you will definitely get at least one question on this also, because this is the trend these days, identifying the type of the language, decidability, and then the third topic is as we discussed, that is closure properties. Generally, we get 2 to 3 questions, one question on each of them in all the GATE exams. Last 4 or 5 years, we are getting the questions, right? Let's see the theory. So while doing that, always remember, we are going to just keep some 10 things in mind about all the languages. I'll do it for regular languages first, then for context-free languages, then for deterministic context-free languages, then for recursive languages, then for recursive enumerable languages, and also for context sensitive languages, right? Let us see what the table is. You can make it in the tabular format also. I will write it for each language one by one, right? So let's see what are the properties that we have for which we are going to check the decidability. The first property that we have is emptiness. Just a second. The first property that we have is membership. So let's talk about membership. So when I say membership, you have to check that whether a string belongs to the language. I'll also explain the meaning of each and every property also, so that you guys get it properly. You can also make it in a tabular format parallelly if you want so. Now, so membership, that is W is belonging to L. I'll write it here so that we have more space. I can make it a table for the same. So it means W is belonging to L, right? Then the property that we have to check is emptiness, membership, emptiness. I'll write the list for you and then I'll explain it one by one. Then is completeness. Then we have equality. Then we have subset. Then we have equality, subset. Then L1 intersection L2 is phi or not. Then we have finiteness. Right, rest we'll write on the next page. Then we have complement. Complement is closed or not. Then we have intersection is closed or not. Is closed or not. And the last thing that we have is L regular. So these are the 10 properties which we should have in mind, and believe me, based on these 10 properties you will be able to solve each and every question that comes in GATE, right? And we'll solve a few of them here only, right? So now let's see for regular languages, which of these properties are decidable. As far as regular languages are concerned, all the properties are decidable. By by tick I will mean that it is decidable. So membership is defined in, so let me define each property first, and then I'll say how to remember it, right? So let's see membership. So when I say membership, it means W belongs to L or not. Okay, right? So again, so the properties which you guys are suggesting, Kundan, like ambiguity and disjointness, these can also be solved using these properties. So you don't need to remember a lot of stuff. I am telling you the minimal stuff which needs to be revised. If you remember that much stuff, then you can derive other things also, right? So again, so let's go back. Over here. We have emptiness. Emptiness means that whether the language is phi. Completeness means whether the language is sigma star. Equality means whether the language L1 is equals to the language L2. Subset means whether L1 is a subset of L2, where L1 and L2 are two languages of a particular type. Whether L1 L2 intersection is L2 is phi is not, that is also we can check whether we can tell whether it is decidable or not. And then is finiteness, whether the language is finite or not. That means whether the language is finite or infinite, that whether we can check that or not, that is finiteness. And then we are checking whether the complement is closed or not. When we say complement is closed, what do we mean by closure? That means when we take a language of a particular type and when we do a complement of it, whether do we get the same language or not, that is called closure. For example, if we do intersection and if we ask whether the intersection is closed or not, we mean that whether after doing L1 intersection L2, whether we are getting the same language or not, right? So for example, L1 is a regular language, L2 is a regular language, and I do L1 intersection L2. Can I say with confidence that L1 intersection L2 is going to be a regular language or not, whether it is decidable or not? That is what we are discussing now, right? Now, similarly, intersection is closed or not, I briefly explained to you. And is L regular or not, whether the given language is regular or not, because we know that by the Chomsky hierarchy, so for example, if it is given that the language given is a context-free language, right, it might also be regular too, right? So every context-free language is not regular, but every regular language is context-free because of the Chomsky hierarchy, right? So we want to check that whether the given language is regular also, whether we can decide it or not, right? Is it okay till this point? Right. So now let's see, for the regular languages, all these properties are decidable. So you can make a note of it. All these properties are decidable for regular languages. Okay. So then comes context-free languages. For context-free languages, only 3 properties are decidable, right? For context-free languages, only 3 properties are decidable. That is membership, emptiness, and finiteness. Rest all is not decidable. Rest all is not decidable. This is for context free languages, right? Now let's check for context sensitive languages. So let's check for deterministic context free languages first. Let's check for deterministic context free languages first. For deterministic context free languages, all these three properties are already defined. Membership, emptiness and finiteness are defined. Along with it, it is also closed in completeness. Equality subset is not closed. This is also not closed. This is not decidable. And complement is decidable. Intersection is not. Is L regular? That is also decidable. That is also known to us, right? Since it is closed in complement, emptiness is decidable, therefore completeness is also decidable, because if something is empty, the complement is completeness, right? Is it okay? So emptiness is a complement. The complement of emptiness is completeness. Since emptiness is decidable, the completeness is also decidable, right? Then we have context sensitive languages. Again, mind you, when I say something is decidable, that means you can write an algorithm for the same. That is, you would be able to stop in finite amount of time. Then only we'll say that it is decidable, it stops in finite amount of time. That is, you can make a recursive, you can make a halting Turing machine for the same, right? That is, the language is recursive. Rather, this property, checking this property, if we make a machine for checking this property, that machine will be recursive. We solved the question on this, right? Okay, so let's see regular, CFL, DCFL, then we have CSL. When we say CSL, only two things are decidable, that is membership and complement. Rest everything is undecidable. For context sensitive languages, only two things are decidable. And the same story also goes for recursive languages also. I am not repeating it. The recursive languages and context sensitive languages have similar decidability as far as these 10 parameters are concerned. Is it okay? What are recursive languages? For which we have a halting Turing machine. Is it okay? Membership and complement. Yes, Kundan, you are correct. Perfectly correct. Okay. So yes, regarding ambiguity, as you are saying, it is ambiguity and disjointedness is again, it is decidable for DCFL only. For CFLs, we cannot say that. Ambiguity is an undecidable problem. You are correct while saying so. Again, yes, Kundan, we are coming for recursive enumerable languages. I just discussed recursive languages. I am coming to recursive enumerable ones. Let's see recursive enumerable languages. For recursive enumerable languages, what do we mean? For which the Turing machine does not halt. Okay? So for recursive enumerable languages, only intersection is closed, everything else is, intersection is not decidable, everything else is decidable. Sorry, ulta. So everything else is undecidable, only intersection is decidable. This is for recursive languages also. By recursive, I'll write as REC because that will confuse with regular language. And recursive enumerable languages, only the intersection is decidable, rest everything is undecidable, right? So maybe you guys can take a picture of this and this will help you in solving the questions that we are going to solve now. Yes, Kundan, they are not, membership is not decidable for recursive enumerable integrators, right? So you can take a picture of this or maybe a snapshot of this so that you can solve the questions that we are going to solve now. Okay. So let's go back. And this is basically recursive. Don't confuse it with the regular language, which is written in the front. Is it okay? Have you guys, should we move ahead with the next question? If you keep this table in your mind, you should be able to solve all the gate questions. None of the questions you'll be stuck, right? This much theory is enough, right? So recursive enumerable is not closed in complement. No. It's not that. Recursive enumerable is only closed in intersection. Did I mark it incorrectly? Let me check. No. It's only closed in intersection, not in this. Right? Right? So just take a snapshot of this. This will help you in solving the questions that we are going to solve now. I'm just giving 1 second for taking the snapshot of this. 1, 2, 3, and then another 3 seconds for taking a snapshot of this. 1, 2, 3. Right. Now let me give you the next question. Is it okay, guys? So these just 10 properties you need to remember about all the languages, and believe me, you will be able to solve all the gate questions. Right? Let's see another question. So here is the question for you guys. Which of the following is or are not decidable? And the timer is, where is the timer? Here is the timer. So the timer is for 2 minutes. Let's start it. Yes. So yes, guys, could you come up with the answer? Kagan says BC, Kundan says BC, Abhilash also says BC. Let's check. I'll stop the timer. So we say that whether the set difference, so you guys are saying B, C, let me cross check which of the following is or are not decidable. I don't think so. Answer is B, C. Just check, guys. Are you actually getting B, C? It should not be B, C. It should be except the same language is or are not decidable. Okay, let's cross check step by step. Okay, let's check that. Kundan. We'll do it step by step. So whether the set difference of two regular languages is infinite. That's the first question that is being asked. Whether the set difference of two regular languages is infinite. Now we know that regular languages are closed under set difference. Now the closure, this is a question which is a combination of closure properties and also of the decidability. I'll discuss closure property after this, but anyways, assume that the regular languages are closed under set difference operation. So therefore, when we do the closure, the two regular languages, we are again going to get a regular language. Now the regular languages, for regular languages, finiteness is decidable. Therefore, this turns out to be decidable. Are you getting this point? Set difference is closed under regular languages, so the language that you get is going to be a regular language, and since it is a regular languages, the property is decidable. I say this property is decidable. Is it okay, guys? Okay, right? Now next thing is whether a given deterministic context-free language is regular. Whether a given deterministic context-free language is regular or not. For DCFLs, this property is decidable. This property is decidable for DCFLs. If you go back, you can check. For DCFLs, this property is decidable. Right? So B cannot be the answer. Is it okay? Kundan, is it okay? Right? So let's go further. Right? So even A is not the answer since it is decidable, B is not the answer since it is decidable. Now, whether two linear bounded automata accept the same language or not. Now LBA is basically context sensitive language, right? So LBA is basically context sensitive language. Is it clear? Now context sensitive language equality is not decidable because only two things are decidable, that is membership and complement, right? So therefore this is not decidable. This is not decidable. And whether a given grammar is context sensitive, so therefore C is the answer. Whether a given grammar is context sensitive. Whether a given grammar is context sensitive, again just have to check the type of the grammar. For context sensitive grammars, we know the format of the grammar. This is a decidable thing. This is decidable. How do you check the context sensitive grammars? Can somebody tell in comment what is the format of a context sensitive grammar? What is the format for the context sensitive grammar? Gagan says why not CFL? Where you are asking, Gagan, like for which? What is the complete question? I didn't get your question properly, Gagan. So meanwhile, I'll discuss. So can somebody tell me the context, the format? So Kundan says left hand side. So it's given deterministic context free, Kundan. Sorry, Gagan, it's written. It's deterministic context free language. Is it okay? The question says deterministic context free language. Whether a given deterministic context free language is regular or not. Is it okay? Yeah. And for yeah. So left hand side length should be less than. Kundan, you wrote the condition wrongly. It should be less than. Right? So over here the format is alpha goes to beta, where mod of alpha should be less than equals to mod of beta, and this alpha can be V union terminal plus and beta can be V union terminal plus. Both of them can be by V union terminal plus. This is the condition. If you can check this condition, an algorithm for the same, therefore it is decidable. It has LHS as combination of non-terminals and terminals without epsilon, and RHS as combination of non-terminals and terminals, epsilon also allowed. No, in RHS it is not allowed. It is allowed in recursive languages, Abhilash. So you mixed up, I think, the recursive languages along with the linear bounded automata. Did you get my point? Right? For unrestricted grammar, what you are saying is correct, right? Right side should be greater, right? That's what I wrote. Mode of alpha should be less than equals to mode of beta, right? You are correct, Kundan, right? So I think this is all about this question. Let's go to the next question. So answer was C. So although I gave it as MSQ, MSQ can also have one option correct, one or more than one are correct, right? I hope you guys know about this. Now this is an MCQ question, and I give you again 2 minutes to solve this. Even I think 1 minute is sufficient for this, but try. Yes, Abhilash. Okay, good. So yes, guys, any answers? Price theorem for L2, D is the answer from Kundan and Gagan. Okay, I'll stop the clock first. So the answer, Gagan says it is D. No, Gagan, it is not D. Kundan says I applies to RE language and machine, I think. Oh, okay. So just guys, please check once again what should be the answer. I just give you 30 more seconds to think this, and then I'll answer this. This seems to be an easy question. You should have done it earlier. But anyways, I'll read out the question. For a Turing machine M denotes an encoding of M. Consider the following two languages. M takes more than 1000 steps on all inputs. M takes more than 1000 steps on some inputs. And then it is asked whether which of the following, whether it is decidable or not. So Kundan says A. Both are undecidable. Why? No, Kundan, it's not correct. It is not correct. Okay, anyways, let me explain now. We have given enough time. The answer is B. Both are decidable. Now again, when we talk about decidability, the machine should stop with a yes or a no also, right? Right? So in general, when I say something is decidable, I should be able to draw a halting Turing machine for that problem. That is what the definition is. Now, think about this language. It says that M takes more than 100 steps on 10,000 steps on all inputs. So whether I'll be able to do it in a finite amount of time, whether the machine will stop or not, it's very simple. You think about this, you have to run on every input only 1000 steps. If all the steps are not stopping after 1000, then the answer is a yes. If at least one stops after 1000 steps, we'll say the answer is no. We can do it in finite number of steps for every input. So therefore L1 is decidable. And L2 is nothing but the complement of L1 on all inputs, on some input. If this is decidable, so if this says yes, you make it no. If this says no, you make it yes. So therefore both L1 and L2 comes out to be decidable. You can run the same algorithm in the reverse order. So for example, M takes more than 1000 steps on some input, I am saying, right? So you run it for every input for 1000 steps. If even for single guy it crosses 1000 steps, then the answer is a yes. If it does not stop for more than 1000 steps on some input, right? If for all the input it is stopping before, then the answer is no. Again, within 1000 steps, you will get to know the answer to the question. You have a finite algorithm for doing the same, therefore it is decidable. Is it okay? Gagan, are you getting the point? As far as I see, L2 is just a complement of L1, right? That says for all inputs, that says for some input. Not the complete complement, yes. On all inputs, M takes more than 1000 steps on all inputs. M takes more than 1000 steps on some input. No, it's not the exact complement, I get it, but you can still define a machine for this. This part we can't do because it's not the exact complement. Pardon me for that. This we cannot do. Is it okay? You will run the machine for 1000 steps for every input. And if for all the inputs it is, if at least for one input it crosses, if it does not stop after 1000 steps, then we can say yes, it is okay. If for all the inputs it is not crossing, then we will say no, right? No, for all the inputs you are going to check. The definition is generic. No, also for first one and for the second one. You will take each and every input, but in finite number of steps you will be able to tell for each input, and if the number of steps are finite, therefore the language is going to be decidable. Are you getting my point? Okay. Although they are not exactly complements of each other, but you can define the machine for each of them. Now, what is the trick here? It is very clear. You have to run the machine for 1000 steps for each input that you give. If it is finite number of steps, then you can definitely say it is regular. So it is decidable, sorry, right? Are you getting my point? Now let's see the next question. So the answer L1 and L2 are decidable. Answer is B. Now let's solve the next question. Which of the following decision problems are undecidable? Which of the following decision problems are undecidable? And I'll give you another 2 minutes to solve this. For L2 we have to check only for some specific exact input, right? I get your point, but you have, for every input you can stop in finite number of steps. right? Even for L1 also you have to check for every input, but you can stop in finite number of steps for every input, right? So therefore, I am saying since the number of steps are finite, therefore they are both decidable, right? So Kundan says the answer for this question is BC. Let's check Kundan what others have to answer. Okay, so everyone says okay, is it audible now? Yeah, yeah. So the answer is BC only, correct? You guys are correct. The answer is BC. Yeah. So let's see. So it says which of the following problems are undecidable. We have to find out the undecidable problems. Again, the question is an MSQ based question. Now, given a CSL, whether a string belongs to the language or not, it is a context sensitive language. For context sensitive language, we know membership. This is the membership problem for context sensitive language, which is a decidable problem. This is decidable. So this cannot be the answer. So for context sensitive languages, membership and complement, these are the only two things which are decidable, and also the intersection. But right now it's only talking about membership. So given CFGs G1 and G2, whether LG1 is equals to LG2, that means equality problem in context free languages. Again, equality problem is undecidable. You can see the chart which I made. Equality problem is undecidable. Next is, given a Turing machine M, whether LM is equals to sigma star. Now, this is completeness problem. Completeness problem for Turing machines which are recursive enumerable languages. It is not decidable, therefore it is undecidable. Last is, given epsilon NF is N1 and N2, whether L of N1 union L of N2 is a universal language or not. Again, this is a LN1 union LN2 will be a regular language, because epsilon NFA represents regular languages. The union of two epsilon NFAs will also be a regular language, and for regular languages, completeness is decidable. Therefore, I can say that yes, it is also decidable. So therefore, the answer to this question will be B and C. Is it okay, guys? Right, the answer will be B and C. Right, let's go to the next question. Which of the following decision problems are undecidable? So again, 2 minutes for this. I think you should be able to do within 1 minute itself, but let me set the timer. Let's see how many of you could answer it. Yes, guys. So what is the answer? Okay. Let's see how many of you have answered it correctly. ACD. Yes, all of you are correct. Kaushalya, Abhilash, Gagan and Kundan. All of you have answered it correctly. It's ACD only. And you can directly look out at the table to answer this question. This is a very, very straightforward question on decidability. Right? So it says which of the following decision problems is or are undecidable. So emptiness in Turing machines. Turing machines only one property, that is intersection, is decidable. This goes into undecidability. Undecidable, therefore it is correct. Emptiness in push-down automata, yes, it is decidable, therefore this is not the answer. Completeness in push-down automata. In push-down automata, yes. Wait a minute. Yes, so completeness in push-down automata, it is not decidable. It is only decidable for deterministic push-down automata. Therefore, it is undecidable. Therefore, it is also the part of the answer. Membership in Turing machines. Again, when I say Turing machines, it also means recursive enumerable languages also. Membership is not defined there. So therefore, D is also the answer. So the final answer is A, C, D. Is it okay, guys? A, C, D is the right answer. Right? So let's go. I think I'm happy that most of you could answer it correctly, but this was a very, very straightforward question. Right? Let's see one more question. So yes, so I'll again reset the timer. Just 1 minute for this question. I think that should be sufficient. Yes, Kundan. So when you are saying emptiness property does not hold for recursive enumerable, so membership does not satisfy in Turing machines. Perfectly fine, because when we say Turing machines, it means both halting and non-halting. We have to answer which is satisfied by both of them, right? Kundan, is it okay? Is it okay? Okay. Okay. Others, please answer. Yes, what are the answers we have? Kundan says ABC. Gagan also says ABC. Kaushalya also says ABC. Yes, ABC is the correct answer. Let's see how it is. So, given a context sensitive language, whether L is regular. Now, this is a CSL. In CSL, whether L is regular or not, again this is in CSL only two properties are defined. Either is one is membership and other is emptiness, right? Sorry, membership and complement, right? So again this is undecidable. So since it is undecidable, it is part of the answer. So A is correct. For an unrestricted grammar G and a string W, whether W belongs to LG or not. So again it is asking about the membership problem in Turing machines. Again this is an undecidable problem. For recursive languages it is decidable. For halting Turing machines it is decidable. For non-halting it is not decidable, but unrestricted covers both of them. Therefore it is undecidable. This is also the part of the answer. Right? Then we have given two grammars G1 and G2, whether LG1 is equals to LG2. Now this is generic thing. It's only about two grammars. For all the grammars the equality is not defined, only it is defined for regular languages, right? So therefore this is also undecidable. This is also the part of the answer. Last is given NFA N, whether there is a deterministic PDA-P such that N and P accept the same language. Exactly, every NFA represents a regular language, and every regular language is a subset of context free language, therefore we'll be able to draw a PDA. So therefore this is decidable. Since it is decidable, this is not the answer. A, B, C are the correct answer. Right? Is it okay? All good? Okay. So let's move to the next question. So yeah, so just 2 minutes for this question too. Right. So guys, this comes basically from decidability, from closure properties. So this was all about decidability. We did some 6-7 questions on decidability, and I think if you remember the table and if you see these varieties of questions, you'll be able to answer all the questions on decidability. This should not be a problem for any of you guys, right? Now we are moving ahead towards the closure properties. Although we are falling short of time, so what I propose is we'll cover this in the next session, but at least let us do this question, and then maybe we can stop the session, and maybe tomorrow when we start, we'll start from closure properties only. But let us first answer this question, then I'll set up the agenda for the next discussion. So okay, so Kundan, maybe you take your time to find out the exact answer. So the remaining, this is the last question that we are doing on closure properties now. Although I intended to do it today itself, but anyways, we will cover this along with the remaining topics in tomorrow's class. But what all we are going to discuss, we'll discuss here, right? So everyone has a different answer. Kundan says BC, Gagan says ABC, Kundan again says AC. Kundan, what is happening? You are changing your answer every moment. So give the final answer. So what is the final answer for the same? Kundan, you are incorrect. Gagan, you are also incorrect. Abhilash, you are also incorrect. All are incorrect. Just think for one more minute and then I'll answer this for you guys. Just think for one more minute. Correct, A and C are the answers. Gagan, BC is not the answer. Kundan is correct here, AC. What about Abhilash? What do you think? What is the answer? I think I'm not muted. Is it audible now? Is it audible now? Kundan, can you hear me? Is it audible? Yeah. Okay. So the answer is AC. Right. So let's see why it is AC. We'll solve this question and then let us set up the agenda for the next discussion. Right. So if L1 is a context-free language, it is a CFL. It is given to us. L2 is a regular language, that is RL, which is also given to us. Which of the following is or are false? That's the question that is being asked. Now, so which of the following is or are false? So we have to tell the false statements. So again, one is CFL, other is a regular language. Let's see, I'll start from the bottom. Answer is AC, I already told you guys. So negation of L2 is regular. Now regular negation or the complement of L2 is regular. Regular languages are closed under complement. We'll see the closure properties tomorrow when I'll briefly discuss the theory for 5-10 minutes so that you are able to solve all the questions on the closure properties too. Right? So we say that negation of L2 is regular. When I say this, what does it mean? Complement, sorry. The complement of L2 is regular and complement in regular languages is closed. Therefore, this is correct. But what did I ask? It is false. So D is not the part of the answer since it is correct. Next is negation of L1, that is complement of L1 is context free or not. Again, context free languages are not closed under complement, intersection and set difference. We'll discuss this tomorrow in detail. But since L1 is not context, so this, again it is not context free, it is not closed. Therefore, this is the part of the answer. Now, session on compiler design also. Yes, Kundan, the session on compiler designs is scheduled on 4, 5 and I think 29th. We have a session on compiler design too. So tomorrow I have a session on theory of computation, and day after tomorrow we'll have a session. Or on Tuesday we are going to have a session on compiler designs, right? Okay. So now L1 intersection L2 is context free. Now L1 is a regular language. L2 is a regular language. This is a context free language. So when we will discuss the closure properties in detail, you must be knowing this fact that intersection of a context free language with a regular language gives you back the context free language. It is closed in that. So therefore L1 intersection L2 is, this is a true statement. Therefore it is not the part of the answer. Now L1 minus L2, this is an interesting one which says L1 minus L2 is not context free. How to do this? We can write L1 minus L2 as L1 intersection L2 bar. Can we do that, guys? L1 intersection L1 minus L2 as L1 intersection L2 bar, because suppose that this is L1, this is L2, L1 minus L2 is this area. L1 minus L2 is this part of the Venn diagram, and if I take the intersection of L1 with L2 bar, so now let us try to draw it the other way around. This is L1, sorry, this is L1, so this is L1 and this is, say, just a second, this is L1 and this is L2, this is L1 and this is L2, just a second. So L1 and L2 are known to us, and I say that L1 intersection L2 bar. Now this is my L1 intersection with L2 bar, which is this entire area, L2 bar. So this entire area, not in L2 but in this. So only the intersection will be this part. So it can also be written it like this, L1 intersection L2 bar. Now you know that L2, that is the regular languages, are closed under complement. This is regular language, this is a context free language. Context free languages intersection with a regular language gives us back a context free language. We already know this. Therefore this is going to be context free. This is a false statement. Therefore it is also the part of the answer. Answer is A and C. Most of you answered it correctly. Right, guys? So this is all about the closure properties. We have just done one question. We'll do 4 or 5 more questions, and I'll also summarize the table for you that you have to remember so that you can solve all the questions that come in GATE exam based on the closure properties, right? So what is the agenda for tomorrow? When we discuss a session on theory of computation, let us set out the agenda. Now you understand this. In theory of computation, mostly we will definitely get a question on identification of the type or identification of the class of the language, and we have covered it in detail. Then on decidability, definitely we generally get a question on this, and closure properties, which we also intended to complete today, but never mind, we'll complete it tomorrow in the beginning of the tomorrow's lecture. The closure properties we'll discuss tomorrow. So definitely short we are going to have one question on each of these topics in most of the cases. So from this region you can expect 2 to 3 questions which we have covered in lecture 1. Now all the remaining topics will have another 1 or 2 questions, because the weightage is never more than, so either 1 or 2 questions are left from the other topics, which will make it to 3 to 5 questions which are generally coming from the TOC paper. So now what are those topics? Let me just briefly summarize. This one part we are going to discuss tomorrow. What is the second part which we are discussing tomorrow? So closure properties, as I said, we are discussing in detail, one thing. And what else we are going to discuss tomorrow? The questions on finite automata and regular languages. This is again a heavily, regular expressions, again a heavily asked topic. Regular expressions are a very heavily asked topic in the GATE exam. We will cover regular expressions first of all, and we'll also see questions on finite automata, maybe the questions on NFA, DFAs, and right, or the epsilon NFAs. All this we are covering tomorrow, or the specific questions that come on push down automata or the Turing machines, like which are related to the construction. Identification we have done today, but which are related to the constructions. For example, a machine is given to you, you are asked to fill out certain configurations which were not there, these kind of questions, or the questions on the grammar, the language represented by this grammar. So the language represented by this grammar or the language generated by this grammar, these kind of questions are also very common. So all this comes in 1 to 2 questions, and this part comes in 2 to 3 questions, which is the total is 3 to 5 questions that we get in generally on TOC. So all this part, we'll do 1 or 2 questions on each of them tomorrow, and we'll do some 3-4 questions on closure properties. As I said, this is an important topic. 3 to 4 questions we will do tomorrow, and we'll do 1 or 2 questions in each of these topics so that all this is also covered, right? So this we will discuss in detail. Thanks, Kundan. So this is all about today's session. We will discuss in detail tomorrow regarding the remaining topics that I have highlighted over here, and see you all tomorrow at 6 p.m. again. And as Kundan asked, the session on compiler design, it is scheduled on 29th, right? So see you guys tomorrow. Yeah, thank you so much.